Hi everybody. In this video, we're going to talk about equations that have two variables in them. So far in all of the equations that we've been working on, there's only been one variable. Usually it would be x. And we might have more than one instance of that variable. So for example, we might have an equation that says 5x equals 3x plus 7. So there would be an x on the left side and an x on the right side, but it was still just the one variable x. Now we're going to look at some equations that have two variables. Even though there's just one equation, it has two variables in it, an x and a y. Now, one equation with two variables will have an infinite number of solutions, assuming it has any solutions at all. So, for example, I could come up with an equation here that says x plus y equals x plus y plus 2. And there are no numbers that I could plug in here, one for x and one for y, that would make this equation true. So for example, if I plugged in, if I plugged in 1 everywhere that I saw an x, and I plugged in 4, let's say, everywhere where I saw a y, then this would be 1 plus 4 equals 1 plus 4 plus 2. So I would get 5 equals 7, which is obviously not a true statement. And there are no numbers that I could plug in here for one for x and another number for y to make both sides here the same. So these equations can have zero solutions, but assuming they have any solutions at all, there will be an infinite number of solutions. So for example, this equation over here does have solutions, and in fact, there are an infinite number of them. So what numbers could we think of, one number for x and another number for y, that we could plug in here to make this side equal to 8? Let's just try, what if I wanted the x number to be 0, then what would the y value have to be? So let's just write the equation here. 2y minus 4x is equal to 8. If x is 0, then we get 2y minus 4 times 0 equals 8. 4 times 0 is 0. So I have 2y minus 0 equals 8, but anything minus 0 is just itself. So this is 2y equals 8, and then I could divide both sides by 2 to cancel this out, and I get y equals 4. So when x is 0, y is 4. And let's just check that by taking our original equation and plugging in both of those values, x, 0 for x, and 4 for y. So 2 times 4 minus 4 times 0 equals 8. 2 times 4 is 8, minus 4 times 0 is 0. So I get 8 minus 0 is 8. So I get 8 on the left side, and I already had 8 on the right side. So I get 8 equals 8, which is good. So this is a solution to the equation. Are there any other solutions? Well, yes, there are. If you've been listening, then there are an infinite number of solutions, but I'll just find one more. So is there a solution for this equation when y is equal to 8? And if there is, then what would the x value have to be? Well, to figure that out, all we would do is, let me just erase that whole thing and then just put that back in there. Okay, well, to figure this out, when y is equal to 8, what would x have to be to make both sides here the same? Well, again, we'll just write the equation and we'll plug in the value that we have, which is 8 for y. And we'll solve for the value that we're looking for, which is x. So this would be 16. So I have 16 minus 4x equals 8, and then I could subtract 16. This is like an invisible plus sign there, so I could subtract to get rid of it. So subtract 16 from both sides, and I get negative 4x equals, that would be negative 8. 8 minus 16 is negative 8. And then divide both sides by negative 4. Okay, so that cancels there, and negative 8 divided by negative 4 would be positive 2. So I get x is equal to 2. So when y is equal to 8, x is equal to 2. Okay, so that would be another solution. So something to keep in mind here, let's just check that solution. So when x is 2, y is 8. So that means I'm going to take out my original equation, but just replace the y with 8 and replace the x with 2. And this should be a true statement here. This side should be the same as this side. So that would give me 16 minus 8 when I multiply these things. Okay, 16 minus 8 is 8, so I get 8 on the left and I had 8 on the right. So yeah, so this is another solution to this equation. And of course, we don't have to stop there. If you want to find even more solutions to this equation, then an easy way to do it is to just pick any number that you want for x and then plug it in here and then figure out what y would have to be. Or you could go the other way. You could pick any number that you want for y and then plug it in here and figure out what x would have to be. Okay, so and if you keep doing that, you'll see that there's no end to it. There are an infinite number of solutions to this equation. And it's important to understand what we mean here by solution. So keep in mind, what we mean by solution now is not only a value for x. Every other time, in every other video, when we were talking about a solution, we just meant the value for x that you can plug in to make both sides the same. But now a solution doesn't only mean x, it means x and y, a value for x and a value for y. Okay, so this by itself is not a solution, and this by itself is not a solution, but both of these numbers together are a solution to this equation. And another way of writing that is by using this notation, the coordinate notation, where we put parentheses, and then we put whatever the x value is, we put that in front of the comma, or to the left of it, and whatever the y value is, we put that after the comma, or to the right of it. So 0, 4, that's one, so even though it's two numbers, it's one solution to the equation, okay? And another solution would be 2, 8. And you can find more solutions if you want. There are an infinite number of them. What about this equation over here? Can we find some solutions to this equation? Well, the answer is yes. First one we can find easily. If I plug 0 in for x, then what would my y have to be? So y equals, I'll just replace the x with 0 and keep everything else the same. So 0 squared, or 0 to the second power, means 0 times 0, which is 0. So I have y is equal to 0 plus 1, which is 1. So when x is 0, then y is 1. And to check that, we can just plug in, here was our original equation, right? So we can just plug in 0 for x and 1 for y, and just make sure that both sides really are the same. And you can see here that, yes, we would get a 1 on the left and a 1 on the right. So this is a solution to this equation. What about if y is equal to 2? Can we find what x would have to be if y were equal to 2? So what we're going to do is we're just going to plug 2 in for y and just solve the equation for x. So we can solve that by subtracting this 1 from both sides. That would cancel there. Then we have x to the second power is equal to 2 minus 1 is 1. Okay, and now we have x to the second power is equal to 1. So what does that mean? That means that whatever x is, if we take it and we multiply it with itself, it should be equal to 1. Can we think of any numbers like that? Can you think of a number that when you multiply it with itself, you get 1? Well, something that might come to mind is the number 1. So 1 could be a solution here because 1 squared is equal to 1. So x could be equal to 1, but another solution actually, so 1, 2 is a solution, but there's another solution that has 2 for the y value and a different x value, and that is when x is negative 1, because negative 1 squared is also equal to 1. Negative 1 squared means negative 1 times negative 1, which is also equal to positive 1. So negative 1, 2 is also a solution to this equation. And to see that, we can just take these values and plug them back into the original equation. So x was negative 1, y was 2. And we should see that both sides end up being the same. -1 squared means -1 times -1, which is +1. So I get 1 plus 1 on the right, and I have 2 on the left, and then 1 plus 1 is 2. Okay, so I have 2 on the right side, and I also had 2 on the left side, just from plugging the 2 in for y. So both sides are the same, so that's good. So that means that this, which we can write in coordinate form like this, is a solution to this equation. And the last one that I'll do here is, can we find an x value that would make this true if y is equal to 5? So let's plug 5 in for y. And then let's see, we'll subtract 1 from both sides. We get x to the second power is equal to 4. And now can we think of a number for x that when we square it, so when we multiply that number with itself, we get 4? Well, there are actually two numbers like that. 2 times itself, 2 times 2 is 4, but -2 times itself, so -2 times -2 is also +4. So that means that 2, 5 is a solution to the equation, and -2, 5 is also a solution to the equation. We also found 0, 1 here, and we found 1, 2. So we found 5 solutions here, but there would in fact be an infinite number of solutions to this equation, meaning when we plug this in for x and we plug this in for y, and we evaluate both sides, they turn out to be the same. Okay? So I'll just show you. If I did it over here with, let's say, 2, 5, so x is 2, y is 5, is this really a solution? Well, let's check it. So 2 squared means 2 times 2, which is 4. It means 2 times itself, and so that's 2 times 2, which is 4. Okay, and 4 plus 1 is 5. So yeah, both sides are the same. Okay, so next thing I want to talk about in this video is, we have all of these solutions for these equations. What can we do with those solutions? Well, we can take them and we can plot them on a graph. Okay, so we can plot the solutions on a graph to easily see if the equation is a function and what type of function it is. So let's scroll down here. I've already taken these solutions and plotted them on these graphs here. So remember, our solutions for the first equation, 2y minus 4x equals 8, they were 0, 4, and 2, 8. Okay, and then I'll just come down here, and in coordinate notation, that would be 0, 4, and 2, 8. So you can see what I did here. 0, 4 means 0 on the x-axis. So here's 10, 8, 6, 4, 2, 0 on the x-axis, and then 4 on the y-axis, and that's where I put that dot right over there. So that is one of the solutions to this equation. Another solution was 2, 8, and the dot that represents that solution is this dot right over here, where x is equal to 2. You see on the x-axis, that's 2 right over there. And y is equal to 8. You see, this is the y-axis over here. And so on the y-axis, we have a value of 8. So that's that dot over there. And in fact, if we kept doing that, these are not the only two solutions to this equation. Like I said, there are an infinite number of solutions to the equation. So if we got more solutions and just kept putting dots wherever those solutions were, we just kept doing that, there would be even solutions between these solutions, right? So we could just fill up a whole line with solutions like that, and each point on that line represents a solution to this equation. So for example, assuming that I drew this line correctly, I should be able to take any point on that line and plug the x value for that point in here and plug the y value in here and get both sides of this equation to be the same. So let's just try doing that. Let's try this point on the graph right over here. So that has an x value of -5. You can see right between -4 and -6, this must be -5 over here. Let me just write that in there. And so that was on the x-axis. Now on the y-axis here, what do we have? We have -6 on the y-axis. So this point should assuming that I drew this line correctly, this should represent a solution to this equation. Well, let's plug it in and check. So we have 2y minus 4x equals 8. If I plug in my my x value, which was -5, and my y value, which was -6, and then I just evaluate this. I'm keeping everything else the same. I'm just replacing the x and the y with those numbers from the graph. Then 2 times -6 is -12. 4 times -5 is -20. But then I have this minus sign out front also. So that's minus -20. And then I'll just keep this the same, equals 8. So minus negative becomes plus. So I have -12 plus 20 is equal to 8. So -12 plus 20 is actually +8. So I get -8 on the left side and also negative, and I had to begin with -8 on the right side. So yeah, both sides are the same, which means that this -5, remember the x value goes first and then the y value. So -5, -6, that is another solution to this equation. And in fact, any point on this line would be a solution over here. And it doesn't have to be with whole numbers or integers. So for example, I could pick this point right over here, and you can see that that is at -2.5 on the x-axis, and it's at -1 on the y-axis. And if we plug those values in, so replace the y with -1 and replace the x with -2.5 equals 8, right? So this would be -2 minus, then 4 times -2.5 would be -10 equals 8, and becomes plus. So we have -2 plus 10 equals 8, and that's 8 on the left, and we had 8 on the right. So yeah, so any point, not just at these whole number positions, but any point at all on this line is a solution to this equation, even the fraction or the decimal values for x and y. Okay, and then finally over here, so these dots are the solutions which we already found. So you can go back in the video. So we already found the solution 0 for x and 1 for y. So that would be this point over here, which is at 0 on the x-axis and 1 on the y-axis. Then we also found 1, 2, and -1, 2. And we found 2, 5. This is a 5 right here, halfway between 4 and 6. So 2, 5, and -2, 5. Remember, you always put the x value first, so -2 on the x-axis, and then the y value second, 5 on the y-axis, right? -2 on the x-axis here, +5 on the y-axis over here. Okay, but these are the 5 solutions that we found, but there are an infinite number of solutions. And in fact, any point on this curve here is a solution. For example, I could take this point right over here, which is, that's 3 on the x-axis and 10 on the y-axis. So I'll replace my y with 10, and I'll replace my x with 3. And so 3 to the second power then. And 3 to the second power is 9. It means 3 times 3, which is 9, plus 1. You can see both sides are the same here. So, and you can do that with anything. Any point on this line, when you plug in the x here and the y here, both sides will turn out to be the same. Okay? So the last thing that I wanted to say is, when we do that, when we plug all of these, when we plot all of these solutions onto a graph like this, so we have a nice pretty line here, or we have over here what's called a parabola, then we can easily see if it's a function, and if it is, what type of function. So we could do that by using the vertical line test. So I can draw vertical lines at a bunch of different points on this graph, and I can see that all of my vertical lines intersect with the graph only one time. So that means that for each input of x, there is only one output. So yes, in fact, this is a function. And what type of function would it be? This is what is called a linear function. And it's not hard to see why it's called a linear function, because when we plot all of those solutions on the graph, then we get a straight line. And you can see that a word that you can see inside the word linear is line. So it's an easy way to remember it. And yes, there are other words in there, like there's also the word ear in there. And let's see, the word near is also in there. So you can have a little bit of fun. You can find all the words that are in this word. But the word that we're really interested in here is line. Okay, so a linear function is just a function that when you graph all the solutions to it, you get a straight line. This over here, is this a function? Again, we can do the vertical line test. So we can see that for each input of x, there's only one output for y. So yes, this is another function, but it's not a linear function because it is simply not a straight line. Okay, this is what we would call a parabola. All right, so I believe that is it. Thank you for watching and have a great day.